Okay, I'm going to give you guys one more, going to go through one more example from chapter 22. I believe this is number 56. I'll put it in the title. I don't remember for certain. But basically, we have a charge, and we have a point charge, and we are given the fact that the flux through some surface equals, oh shoot, what was it? I'm going to, 235? Okay, let's... Yeah, okay. Sorry. 235 Newton meters per coulomb. Newton meter squared? Should be, yes. Newton meter squared per coulomb. Okay, so that's what we are given. And I'm sorry, this is the flux through a 15 centimeter diameter, well, radius or diameter, I don't recall, doesn't matter. We'll pretend it's radius. We'll say that this 15 centimeter radius sphere here. And the question is, what if we change this to, I don't remember, but I'll say 27.5 centimeter sphere? Well, and the question. All right. And did we freeze up? I don't know if this works or not. All right. It looked like it froze up for a while. I'm going to hope for the best. All right. Where are we? 230. Oh, okay. So what is this flux? Well, we know this flux is E dot dA for a closed volume, and we know it's equal to the enclosed charge over epsilon 0. So what shape is this relationship, is Gauss's law? What shape is that true for? The answer is it's true for every single shape. And so any shape that has this Q enclosed is going to have an identical flux. So the question is, what will the difference be between the flux for this sphere and the flux for that sphere? And the answer, of course, is there is no difference. It's still the same charge that's inside here. There's no new charge added. Therefore, the flux is exactly the same. And it would be the same if it was a cylinder, and if it was a huge cylinder, and if it was an octagon. You could do this to anything, and the total flux would still be the same. So then the question is, what's the charge? So the charge is now, we are given the flux. So remember, this is the definition of flux here, flux through this surface. This is the definition of flux. So do we need to calculate this at all? No, we already have the answer. We've been given the answer, so you don't need that at all. All you need is this, that the flux is equal to the charge divided by epsilon 0. So we are given the flux, which is, well, I'll write out one more thing. So we want to find the charge is what we want to find, and we know that the charge over epsilon 0 equals the flux, the total flux, so we know if we multiply the flux by epsilon 0, we'll get to that. So, that's it. We're done. All we need to do is put our numbers in. We have 235 Newton meters squared per coulomb, and we have epsilon 0 is 8.9 times 10 to the minus 12. Oh, gosh, what is it? Coulomb squared per Newton meter squared. Yes. Okay, so Newton meter squared, Coulomb cancels Coulomb there, so all we have is 2.4 times 8.9 times 10 to the minus 12 Coulomb, so we have, 2.4 times 10 to the second. 2.4 times 10 to the second, which means I'm just going to go ahead and include that in here. So it's now 10 to the minus 10 instead of 10 to the minus 12. So I have 9 times 2, 9 times 2.5. So that's, 18 plus 4. So that's about 22 times 10 to the minus 10, or 2.2. Oh, let's not take this to a different level. So 2.2 times 10, that would not be a 10. 10 to, let's see, minus 10, 22. We're going one more pot to minus 9, and this is in coulombs. So 2.2 nanocoulombs is the answer that I come up with. I actually did not check that in the book, and obviously I kind of rounded a few things in this calculation, but I think that's enough to give you an idea. And that's it. Actually, I'm going to go ahead and check what the book says too, just to be sure. So the book says 2.08 times 10 to the minus 9 instead of 2.2. I'm going to consider that close enough for my calculation. Like I said, if I had my calculator here, we would calculate something a little different. So they got 2.1 times 10 to the minus 9. I got 2.2. That's fine. And that's it. Just wanted to give you a little bit of an idea of a numerical example that also illustrates the conceptual idea that once you have the flux, you do not need to calculate it any longer. It's given to you.